Now we are going to start with a new topic, that is halides. As you all are aware of the periodic table, you know that the 17 group actually comprises of halogens, that is the salt producers, that is fluorine, chlorine, bromine and iodines. So when they react with some compound or something, they form their respective halides. So one of the important that the halide compound is the haloalkanes. So this is what we are going to start in this chapter, right? So how the you can say that haloalkanes are obtained actually? They are obtained by replacing one or more hydrogen atom from alkane. See, like suppose I have an alkane, what I am doing is I am adding one halogen and replacing an hydrogen. So what I'll get Rx plus H2. This Rx is called as haloalkane. That means alkane with like we have replaced hydrogen of the alkane, minimum one hydrogen, and we have replaced it with the halogen and we get the haloalkane. So this is what is the haloalkane, or you can say the halide compound. So the basic halide compound is the haloalkane, which is obtained by replacing one or more hydrogen. Also you can replace it, but minimum when the one hydrogen is replaced with the halogen, then also it is called as haloalkane. But you can add more number of halogens also, and the time you can add halogens till the time it has the replaceable hydrogens. So we can say that haloalkanes are obtained by replacing one or more hydrogen atoms of alkane. This is what you can express, that RH, minimum we are talking of 1H, I am adding a halogen, subtracting this hydrogen, and what I get as a result the haloalkane. If I talk about the general formula, so you know that the general formula for alkane is CnH2n plus 2. But when we talk of haloalkane, it is actually CnH2n plus 1 dot X. So this is the general formula for this one is for the haloalkane. Now you know that like in haloalkanes we know there is a bond between the carbon and the halogen. As we know that halogen is smaller in size as compared to carbon, so we can say that it is slightly electronegative and it is less electronegative. So as a result, this covalent bond will become a polar covalent bond because it will attract the shared pair more toward itself, and as a result it will get a partial negative charge and it will get a partial positive charge. So that means this bond between the R and the halogen is actually a polar covalent bond, right? Means it's not you can say it has a dipole interaction in it. Now depending upon that whether this carbon which is attached to the halogen is sp3 hybridized or it is sp2 or sp hybridized, we have different types of halide compounds. One is the haloalkane. So as you can see, these all sp3 hybridized are haloalkanes, allylic halides and benzylic halides. Now what is the difference between them? Haloalkane is generally abbreviated as Rx as we formed here, so it is Rx. And you know that this haloalkane is actually formed by replacing, as I told you, one or more hydrogen atom from the alkane. So whenever you replace one or more hydrogen from the alkane, you get with the halogen you get the haloalkane. So this is something an haloalkane. When the halogen is attached to the means it has been replaced, it has replaced actually one or more hydrogen, it is attached directly to a carbon atom. Allylic halides. Allylic halides are something in which the halogen is attached to a carbon. This is my halogen, it is attached to a carbon, and this carbon is further attached to a unsaturated system. It is further attached to an unsaturated system. So whenever halogen is attached to a carbon and this carbon is attached to some unsaturated system, we call this kind of halide as allylic halides. For example, one more, let's say it's CH2, CH, we have Br, sorry. So this is something called as allylic halide, in which the halogen is attached to the carbon atom and further this carbon atom is attached to some kind of unsaturated system. So it is called as allylic halides. Benzylic halide is that, and also one thing, this allylic halide you can also observe in a cyclic compound. For example, I have a benzene ring in which I have this double bond. So it is attached to a carbon, suppose this is my carbon, and to this actually, or you can say to this our halogen is actually attached, right. So you can say that that this kind of compound is again the the allylic halide. Now the benzylic halide is that in which, suppose I have a benzene ring, right, and to benzene ring there is one carbon atom and to it the halogen is being attached. So that means, or you can say that halogen is attached to a carbon and further this carbon is attached to an aromatic ring. Then it is called as benzylic halide. So in all of the three, the carbon atom to which the halogen is directly linked is sp3 hybridized. Again we will look for that. sp3 hybridized is haloalkane, in which the one or more hydrogen is being replaced by the halogen, that is Rx. Allylic halide, when it is attached to a carbon, which carbon is in bond with an unsaturated system. Benzylic halide, when it is attached to a carbon which is in bond with an aromatic ring. So this is where you can see that carbon is sp3 hybridized. And coming to this sp2 and sp hybridized, we have two kinds of compounds, vinylic halides and aryl halides. Vinylic halides are something in which the halogen is directly attached to the carbon which is a part of unsaturated system. So actually there is a difference between the allylic and the vinylic. In the allylic it is attached to a carbon which is further attached to an unsaturated system. But here the halogen is attached to a carbon which is involved in the double or triple bond. That means it is involved in the unsaturated system. So this is what is the sp2 hybridized here. It can be sp also, because when it will be triple bond, it will be sp hybridized. So whether it is double bond or triple bond, but the carbon is involved in an unsaturated system, then it is something called as vinylic halide. Now aryl halide is that in which the halogen is directly attached to a benzene ring. When the halogen is directly attached to the carbon which is a part of aromatic ring, then it is called as aryl halide. Now as you all know, now sp3 hybridized carbon the halides, and you know that sp2 and sp hybridized also. So now we can have these things as 1 degree, primary, secondary, tertiary, quaternary, we can have that. Now what is the 1 degree? You know that the primary haloalkane is going to be that in which the halogen is attached to a carbon which is either attached to other carbon, or it is not attached to any other carbon, or it is attached to one carbon. So whether it is not attached to any other carbon, this carbon is not attached to any other carbon atom, or it is attached to minimum one carbon atom, it belongs to 1 degree. But when the halogen is attached to a carbon which is further in contact with 2 carbon atoms, then it is 2 degree. And 3 degree, when it is attached to a carbon atom which is in bond with at least 3 carbon atoms, then it is called as 3 degree. So like you can have all these compounds as primary, secondary and tertiary, just depending upon that the carbon to which the halogen is linked to 1 carbon atom or non-carbon atom, then 1 degree. If it is linked to 2 carbon atoms, then it is 2 degree. If it is linked to 3 carbon atoms, 3 degree. So likewise you can have primary haloalkanes, the secondary or the tertiary halides. So this is what is the basic introduction. And coming on to isomerism, so they actually show the chain, position and optical isomerism. Like the chain is that suppose we have a 5 carbon chain and it gets somehow branched into 3 carbon. So this is something called as chain isomerism. Position, we can change the position of the halogen. Suppose if in a chain it is attached to the 2nd carbon, if we make a you can say isomer for that, we can attach that halogen at 3rd or 4th position. And optical is that's how they rotate the plane of polarized light. So this is what is the isomerism. I am not going deep into isomerism in this topic because we have already done in the general concepts of organic chemistry. So if you have any doubt related to the isomerism isomerism shown by the haloalkanes. You can refer to my slide in the general organic chemistry principles, right. So as far it is concerned in this chapter, you should know that actually it undergoes the chain, that is, and deposition, which is part of structural isomerism, and also a stereoisomerism, that is the optical isomerism. So this is what is the general introduction of the halides. Now we are starting with the preparation. So just look at the board. But before we start with the preparation, you should be familiar that what kind of halides, halidic compounds you come across, right?